Hello students, so this is the first tutorial of practical application of your convolutional neural network where we will be using TensorFlow as well as PyTorch. So we have two codes, right? One TensorFlow and one PyTorch code. So we'll be implementing both the codes and we'll build a simple image classifier. Okay, this will be first hands-on after the step-by-step implementation of CNN using Python. So if you haven't done that one, that will give you the intuition of what's max pooling, what's convolution, what's how convolution works, and how the matrix calculation actually happens, how back propagation happens. So by combining all of those, by using the two, regular frameworks like TensorFlow and PyTorch, we'll build these two notebooks. And yeah, so let's get started. So first of all, don't get much worried about all these imports. We'll work later, like every time if there is any requirement, we'll go and see, okay, this is why we have imported this framework. Okay. Yeah. So first, as our data is stored in our local drive, right? So Google Drive, we have stored this train.zip. So it contains images of cats and dogs under one folder named train. Okay. So yeah, let's store this path as a variable first of all. Then we'll use zip file module provided by, it's a Python open source module, right? This zip file. So we'll just import this one quickly, import zip file. So the job of zip file is to provide us one method named zip file, and in this file we'll provide the local path, the downloaded or already situated file, zip file basically. We'll give it a read access. Okay, this R is for read. So once it can read the files, we'll just tell that okay, extract all the files and store it under this temp directory. Okay, so this tmp is for temp directory. So and once this thing is done, then as a standard we'll just close the connection. Okay, so let's just run this one. Okay, and if you don't have this data set, okay, don't get worried. We have, I think, one dog and cat example, right? Data set for classification in Kaggle. So you can search on internet and probably you can sign up and download the data from Kaggle. Okay, so yeah, as you can see, our data got downloaded in temp directory. So if you just came, if you have to move a bit upward, I guess. So okay, yeah, here if you can see in the temp directory, right, you will see there is a train folder that on which you can see all the images. Okay, so this is the job of this portion of the code. So as we have, I think, probably 25,000 images, so it is probably taking time. So anyways, it will load up. Okay, so if now I can directly print the size of the folder, that means how many images are there, it will get printed here. So part of that, okay, you require this OS module. Okay, once the OS is there, it has listing directory capacity. So list dir is nothing but listing the directory. So you'll get a list with all the files or folders in it, and then you just simply do call the length function, right? And it will provide you, okay, this many this many files are there in this directory. So yeah, till now it's basic Python and everything is clear, I guess. So now let's move forward and to work with deep learning basically frameworks, right? You need to organize your data in a orderly manner. So for which we'll define the source directory. So as you can see here, our source directory is this one, right? Under temp, we'll have this train. So this is our source directory, and we'll define three destinations. So as it's a classic deep learning training tutorial, right? So we'll be creating one training for training purposes of data. Okay, and the second one will be for testing, and the third one is for validation. So as you all know, training is nothing but upon which data your model runs. Okay, testing is upon which your model performs your inference, and validation is for internal checking when your model does the training, right? So to get rid of overfitting and all. Okay, so I think my runtime, there is some issue with my runtime, no worries. Okay, so once you have defined all your training directory, testing directory and validation directory, again we are using this same OS, because what right now we are doing, right, it's working with this file system basically, what that's available under this cloud system, right? This GCP provides this collab thing, right? So yeah, let's just quickly rerun it. Okay, as our runtime got disconnected. Okay, so once you have all of your directories, your training directory, testing directory and validation directory, so in case of your command prompt, you used to write mkdir, right, for make directory. So the same thing we'll do here in Python using os dot make dirs, that means make directories. So once this directories will be built, we can then transfer the data from our source to our destination on a orderly manner. So we'll see it. Okay, and what this flag does, this exist okay equals to true. That means if this destination directory is already exists, right? So let's say I am running this project twice. Okay, and in the first run I have already created the directories, right? Then what it will do, it will not create the directories again, right? So till now every line, every portion of the code and understanding is clear what we are trying to do. So we are trying to build one image classification model, basically machine learning model using TensorFlow, and in later point of time we'll implement PyTorch to building the same classification kind of problem. And currently what we are working with the file system where we have downloaded, we have some data in our Google Cloud storage, and we are trying to move that data from Google Cloud, from your G drive basically to your directories of training, testing and validation in a orderly format, in that format which one is required by TensorFlow for performing CNN in top of image data, right? So yeah, now once this training directory, testing directory and validation directory is created, right? It is created, I guess. So if I click on this file section and if I go on this temporary section, I can see, yes, you can see training, validation and testing got created, right? Now under each training directory, I'll be requiring two folders, dogs and cats. In testing also I'll be requiring two folders, dogs and cats, and in validation also same thing. And same flag, if it's already exist, then don't create. So right now is it exist? It does not exist, right? So this code will create all the required directories of dogs and cats under all of these folders now. So if you click on this train and if you click on this refresh, I guess you can see the dogs and cats folders being generated. Okay, it will take some time, I guess. Sorry, not under train, so under training, right? Yeah, so you can see this cats and dogs folders got created. Okay, under training, under testing as well, and under validation as well, right? So where is our validation? Okay, right? Okay, so till now I think everything is clear to everyone. Okay, now let's come to this portion. Okay, so yeah, when you will start building the codes, it will take some time for you to understand what you are trying to do. But once you have that knowledge, right, what you are trying to do, then it will be pretty much simpler, and the codes will become very much familiar to you as you work more and more on this, right? So first, now what we are trying to do here, we have our source directory here, right? And these are our destinations, right, where we want to place all the cats and dogs images to create one data set upon which we can apply CNN, right? this CNN architecture. So yeah, first get all the images from the source directory, right? So that's what this portion of code is doing, right? So this portion, what it is doing, it is nothing but it is utilizing the OS module, and it is basically connecting the source path, right? Okay, and if the path contains file, okay, then what we are going to do, we are just going to list all the image files. Okay, so how you can understand better, let's copy these portions and let's run one by one. Okay, now so if you see our image files, and now if I call this function, right, and let's just print what it contains up to 2, so you can see it contains all the image files names, right? So this train folder, it contains some images around 25,000, right? So you can also validate that, right? So length of, let's say, so it's a list, right? Nothing but a list. So if you call this one, what you will get? You will get 25,000. Okay. So yeah, you see there are 25,000 objects. That means the file names that got stored. Okay. So once that is done, then what we are doing, we are just randomly shuffling the image files. That means the list. We are doing a random shuffle. So yeah, if you again do a in place operation, right? So see, if you do a random shuffle and then you again call this first to index, now you have a different objects there, right? Because it shuffles the orientation of the objects where it placed, right? So yeah, now next what we are doing, we are just calculating the total number of files. We have just done that, right? The same code. That means it will provide this total images will provide me 25,000. So let me just write it down. So we'll have 25,000 number of sorry, not number of codes, number of objects, right? So once we'll have this images, then we'll just create our train split, test split, and validation split, right? So I hope you all have gone through the basic machine learning courses, where you will know what's a training part, what does, what testing part does, and what validation part does. Okay, so we are creating a 60% of training and 20% of testing and 20% of validation. Okay, that means this will contain 60% of 25,000. Okay, this will contain 20% of my 25,000, and this will contain the remaining, that means 20%, right? That means it will also, I can write it, it will contain 15,000, then 5,000, 5,000. Okay, so yeah, once I have the split, I can easily split the data, right? So let's say, as I have already done the random shuffling on the images, right? So even though the, let's say, the images are ordered, it will not be in ordered format right now. Okay, so now let's take the first 60% of the image as training, then take the second basically 20% and testing, and the remaining one as validation. Okay, so this is pretty straightforward index manipulation in list basically. So once this is done, what we have to do, we have to just transfer these files basically from one directory to another directory. Okay, now, okay, so this is one function that we are creating. You always remember till this point. Okay, till this point, I don't think anyone will have any doubt, right? So till this point, everything is clear, right? Now, what is happening before this function? Okay, just ignore about this function. What we are trying to do, we have a source. Okay, here we have 25,000 images, and we need to transfer these images to this three directory, 15,000 here, 5,000 here, and 5,000 here. But there is one catch, right? Your every directory where you have to transfer, there is two folders, right? Cats and dogs. So what we have to do, we have to transfer the files, all the cat related files in cats folder, all the dogs related files in docs folder, right? So that when you are applying the machine learning model for labeling purpose, it will be much more easier. It's a standard, right? So that you don't have to, the model will definitely pick up, okay, so all the images belongs to this folder must be cat, all the images belongs to this folder must be dogs. Okay, so how to do it? Pretty simple, right? You have seen the names of the files. So all the dog images have dog labeled as is, and all the cat images has cat as labeled in the file, right? So what we are just doing, we are just writing one case statement. That means if else statement. Okay, you can also make it as a one liner, but for better understanding, I am just split the code. So if there is dog in the file name, right, then my destination will be dogs folder. If there is cat in my file name, then there will be the destination will be cats folder, right? So and I will apply the same logic to both training, testing, and validation, right? So remember, your training will have now 15,000 images, your testing will have 5,000 images, and your validation will have 5,000 images, right? So within that 15,000 images in training, there might be 10,000 dog images and 5,000 cat images, right? That I don't know. So when we are applying this this copy image function, it will do that automatically, right? And the organization of the folders, right, for the machine learning project will be successful. Okay, so this is what this whole chunk of code is doing, right? I hope everyone have understood it. So once this is done, you can verify. Okay, I don't know, as I have very limited bandwidth of internet, so all the cats images will show up here, all the dogs images will show up there, right? Okay, as you can see, right, in testing all the cat images have start appearing, and in dogs also you can verify that all the dog images will start appearing. Okay, so yeah, file transfer is done. So till now I guess we are good. Now next what we have to do, okay, we have to move the directories. Okay, so what we are doing, we know we are just creating one parent directory, okay, for our sake of safety. Now we have organized the files in the folders, right? Now we wanted to do we wanted to move. Okay, so where we wanted to move, we wanted to move everything, this testing, this training, this validation under this cats and dogs filtered under this parent directory. So same thing, we'll have now 3 directories that will be our source directories, and 1 directory that will be our destination directory. And to move the directories, we'll require this shuttle, this module, and that's why we have imported this module, right? So yeah, in any project, when you see bunch of imports, don't just get picked out, right? It all will make sense at the end, or if you have done projects, it will make sense, right? So this shuttle.move is a method, and in this move method we'll have to pass the source and destination. So in this case our destination is same, okay, cats and dogs filtered, and we'll be passing the source directory 1, source directory 2, and source directory 3 for this movement, right? So once that is done, then I guess all the folders are organized, and we'll have our base directory ready for the project. Okay, so let's just quickly verify that one. Yeah, you can see there is no training, no testing, and no validation outside, right? That means this move method has done its job, and everything is under this. Okay, now if you open, you will find cats and dogs. So yeah, bravo, you have achieved and you have done something, right, with the file system, not with machine learning but with file system, right? So what you have done so far, you have taken a raw source file and you have split it. You have created 3 train, test, and validation split, and within each file you have created dogs and cats labels, and then you organized all those files in all those folders. And once that is done, then you joined everything back again into your final base directory, right? Okay, now once your base directory is ready, right, so then you will get your training directory by joining your base directory with training, and it's in same manner you will get your validation directories. Okay, and directory with training cats and dogs picture. Now it will all make sense, right? Now as I know my training directory, I will definitely get all the labeled cat labeled images from train directory, right? Same method, os.path.join, and I'm just passing my base directory and training for training directory, and then train directory and cats for training images of cats, right? And similarly for dogs, and same we are doing for validation, right? And once that is done, and you can print, let's say, okay, list directory will again list all the content inside one folder. So we can print here, okay, let's just print the content of base directory, train directory, and validation directory, right? So in base directory you will find training, validation, and testing. In train directory you will find cats and dogs, and in validation directory you will find cats and dogs, right? And within this cats and dogs you will find all the images. Okay, so yeah, you can also verify all the names of the, I mean, couple of the names of the what files, to just to check whether your segregation method works or your separation thing works or not. So again, list directory of the cats directory and dogs directory will give you the whole bunch of names that are within a list, and you can also print the length. So let me also print the length to get, okay, whether it's a labeled data set or unlabeled data set it created, right? So length of, let's say, both the cat and dogs images in the training directories. So just copy this one, okay, and copy this one as well, okay, and let's just print it down. Okay, so these are the 5 cat images file name, and these are the dog images file name, and as you can see it's pretty much balanced data set. Okay, and the same thing we are also doing here just for checking purpose. Okay, we have 7,546 cat images in training, and we also have approximately similar number of dog images and similar kind of numbers for validation. Okay, now next set of code is nothing but just printing all of those images that we have for training in a random manner. And here, is there anything to learn in this case, right? In this code, the only thing is to learn how to create, let's say you have multiple images in your data set, and you just wanted to plot everything in a grid manner, right? One after another. So that's why. So this is a 4x4 grid. So the expected is to plot a 16 number of images, right? So that's what it is plotting. So let's just go. Okay, so you have number of rows and number of columns defined, and once you are defining these variables, okay, are holding the images. Okay, and once you have those images, you are just running one loop, and then you are just plotting. Okay, and this will create the subplot grid for all the images. Okay, and you are just making the axis, okay, this grid line or axis, you don't want it to show it. So if you just change it from off to on, then it will show. And then your im read, right? This im read from mat.read, this function will read the image as image and not array, and it will provide you, it will, this plot.image show will show, right? So this is the variable, image variable, and this is this im show will basically print out the image, right? So that's it, I guess, in this code. So yeah, till now you are done with your CNN training organization. Till now you are done with printing all of these images, right? So yeah, now let's move ahead and then build the small model, okay, from scratch. So I hope everyone knows what CNN is, and I mean the basic understanding of convolution, why you require convolution. So if you are not aware of this, you can go and watch this tutorial where I have explained basically step by step convolutional neural net and how to implement this step by step, all those low level details that you rarely will use until and unless you are building something very I mean interesting from scratch. So yeah, what we have to first mention, as we are dealing with image data and we are working with the sequential API, right? So in TensorFlow, building any model, you have two methods. One is sequential, one is functional. So the functional API use case will deal with that later point of time. We'll cover that in our TensorFlow tutorial series as well, and also we'll cover that later in CNN as well. Okay, so yeah, we are currently in this project. We're using it for sequential API. So the first thing you have to provide is the input. Okay, the input is nothing but this image. So I can understand it's a dog image, but the model will not understand like it, right? So you have to provide him or the model. I'm sorry for being sexist here, right? So we are just providing the model. What is the image size? Okay, so the image will be nothing but a array. Okay, so it will have the height and the width and the number of channels. Okay, the RGB channels. So as all these are color images, so we are passing, there are three input channels, and the height and shape we are restricting to 150 times 150. Okay, so first line understood, and we are using keras to implement the input module basically, and as a backend we are using TensorFlow, right? So this is the overall story. This is the overall story of this line, right? And how we are implementing, we are just packaging all of this whatever is written, right? So we are packaging this input under this sequential model to build a sequential model, right? So how we are getting this sequential, same. TensorFlow is the backend. We are using keras module. Within keras we are using the models, and in models, as I have mentioned, right, you also have sequential and many more, right? So we are using this sequential API. Okay, so we got our input. Then what we are trying to do, first thing we are trying to do is rescaling, right? So that the computation will be much more efficient and our training will be much more faster and mostly accurate, right? So same thing, TF keras layer rescaling, we are taking this rescaling method, and as we know that we have to, this image data is nothing but 0 to 255 scale data. So we'll just rescale it to from 0 to 1, right? So this thing is done. That means your input and rescaling factor is done. Now next is building a convolution layer. To build a convolution layer, what we required? We required first of all the filters. Okay, the convolution filters. Second, what we will require, the number of channels. Okay, how many number of filters we want to use. And the third one is activation in any convolution layer, just to bring the non-linearity, okay, or feature. Okay, same thing, TF keras, and from layers what we are taking cont2d. So this cont2d method is what we are using, as it's a two-dimensional array, right? These images are nothing but 2D arrays. So that's why cont2d method we are using. We are basically using all this image from this method, sorry, from TensorFlow, and we are passing, okay, we require 16 number of filters. The filter size needs to be 3 cross 3, and we are just going to use this ReLU activation, right? So once this is done, the next step of any convolution is pooling layer. So yeah, TensorFlow keras layers. So max pooling 2D will provide you a 2 by 2 will provide you the pooling efficiency, and we just want a 2 by 2 pooling layer. So to reduce the size, by half basically. So it will give you a 2 by 2 pooling, and what it will do, it will find the 4 grids, right? 2 by 2 pooling layer means 4 grids, 1 2 3 4, and within that 4 grids, whatever will be my maximum value or maximum pixel value, it will try to localize that in that position, right? So why we use pooling? Basically, pooling does not have any training parameters, right? It is not learning anything, but what it is doing, it is reducing one your image size, and second of all, it is also preserving the properties your convolution is learning, right? Now again we are implementing another convolution layer. Here we are using this 32 number of filters, again 3 by 3 filters, and in activation also we are using ReLU for non-linearity. Then again a max pool layer. Then again we are using another convolution layer here, where we are implementing 64 number of convolution filters basically of 3 by 3, right? Then again max pool. So once this convolution, all these three layers of convolution will learn some properties about this images, right? And what it learns, what are the feature maps, right? That also we'll see later point of time. Okay. So once that is done, what we are going to do first, we have to flatten this network, right? And once the network is flattened, we are going to connect it with a deep neural network. That means our vanilla deep neural network, where we are providing, okay, let's connect with 512 neurons, okay, and let's in this learning also from this 64 3 by 3 method to 512 dense neuron, right? By doing flattening, let's keep the activation as let's keep the activation to ReLU as well here. So till now, all these layers are activation layers, right? And here it becomes again your deep neural network, right? Plain deep neural network. And once this layer we achieve, we are going to throw the final layer, right? In final layer, as it's a binary classification, either it will be a dog or it will be a cat. So it's just going to use sigmoid activation. You can also use softmax here, right? But again, it will be of much more sense if you use sigmoid for any binary classification. And same thing. So this is the overall model that we have implemented. So let's just run it. I hope you have understood, right, the whole process, how to implement and what are the meanings, right? So yeah, and if you have to understand how this Con2D is working, just check out the previous video. Okay. So once this is done, we can print out the summary. So the basic method is model.summary. We can also use plot model. So we'll see in later tutorials how to call that one. So here you can see all the details of about your model. So first your model is doing one rescaling, then it is applying the first set of this two is your first neural networks convolution layer. This is your second layer, this is your third layer. Then once this three layer is done, then you are doing one flattening. Then one you have flattened your data, then you are applying the first dense layer, and then you are applying the final output layer. So in this case, your total learning parameter is about 94 million. Okay, total parameter, upon which there are all the parameters are trainable parameters. Okay, there is no non-trainable parameters as of now. Okay, now once your model is ready, you have built the model. Next thing is for training, there is two major requirement. One is your loss function that you have to define, as we are dealing with a binary classification. So we will provide binary cross entropy, right? For let's say any regression, you will provide MSE, MAE, and all that stuff, right? So here we are providing binary cross entropy. And in another thing is your optimizer for your learning purpose, right? So in optimizer, we are providing RMS prop with a default learning of default is I think dot 10 to the power minus 3. So here we are providing 10 to the power minus 3 at the default one. And from where we are picking up this optimizer, we are picking up this optimizer from tf.keras.optimizers. And in model, you have mostly used tf.keras.layers, right? So these things you have to remember for fast retrieval. But anyway, these codes are all boilerplates. So if you just compile this model, and once the compilation is ready, then you can actually train your model. But before training, you have to create the data. You have to prepare the data in a format in which your TensorFlow model will understand, right? So for that, we are just calling the utils module of Keras, and from this we are using image dataset from directory. So remember, we have made a lot of effort in the very beginning of this project, right? To just organize all the files from train to this cats and dogs filters, right? So that will pay off now. So yeah. So once this is done, what we are going to do, we are going to provide the training directory to this method, so that this method will understand, okay, just take the training dataset from this directory. We have provided the input shape of the images to 150 cross 150. Okay, and we are just right now keeping the batch size to 20, and we are providing additional information as level mode to binary. Okay, so that will it will understand, okay, we have to train a binary classification, right? And if you just run all of this, so you can see your training will have 60% of 25,000 images, right? That means 15,000 files will belongs to two classes in your training, and your by validation 5,000 sets divided to two classes, right? Same thing is you are getting printed here, right? Now your data set is ready, your model is ready, right? Now there are some methods particularly implemented in TensorFlow to fasten your training, basically, right? As a refresher, you can again go through. First thing what we are going to do is caching. We are applying caching method. Okay, what it will do, it will stores the element in memory as you use them, so it will be faster to retrieve if you need them again, right? So this cache method, what will do, it will store the files basically, or the elements or tensors from your hard drive to your memory, that means your RAM. Okay, so that if you required it in later point of time, the retrieval will be faster. Then second one, what we are going to do is shuffling, right? Okay, so it will shuffle the data set randomly, right? Up buffer size 1000 means it will first select a sample from the first 1000 element, then keep filtering this buffer until all elements has been selected, then again another 1000. Okay, so this is what you're shuffling means randomly selection. And then prefetch. Okay, there is another method called prefetch. So it gets elements while the model is training, so it's faster to feed a new data when the current training step is finished. Okay, so what it is doing, prefetching, is while your model is training, let's say some of the model and some of the images, and it is learning, right? At the same time, this prefetch method is already feeding newer data sets, right? It is just creating the path. Okay, so a buffer size set to tf.data.autotune dynamically sets the number of elements to prefetch during the runtime. So if you use this option, right, tf.data.autotune, so we'll see all of this later, right? Or I guess we have already seen covered in the TensorFlow tutorial, so you can check that as well. So it will dynamically select what are the number of elements required to be prefetched. Okay, so for this training purpose or this tutorial purpose, right, we're just keeping the buffer size to 1000. We are prefetching buffer sizes as we have mentioned, as mentioned in the document, right? We are keeping it to auto tune, and just first we are calling the cache function, then we are doing shuffling, and then we are just prefetching, right? And in validation we are not doing shuffling, right, as it is basically a inferential testing. So there if you, even if you do shuffling or no shuffling, it makes no sense, right? So why to do shuffle there, right? And once this is done, we are just calling the fit method. Okay, so this model dot fit method will start the training of the model basically instantaneously, and whatever the output of this training, right, that means your accuracy, your losses, okay, all these things we are storing in this history object, right? So we are not going to run it because it will take at least a good amount of time. So yeah, let's just not run this now, so you can try it later point of time. And once this is done, this is a simple boilerplate code just to function basically for this Google Colab understanding. So you will get one upload button here, right? And you can upload what it called, you can upload your files, right? Once you will upload your files, if it's a dog, it will say it's a dog. If it's a cat, it will say it's a cat. And in that way, okay. And we have set the prediction threshold to 0.5, right? Okay, so that means if it is neither a dog neither a cat, still it will give you some prediction, right? As that's the logic that we have set here, right? So yeah, once these things are done, your basic building block of TensorFlow, basically convolutional neural network model, right, using TensorFlow backend is done. So you have done what is required, right? Your initial first step. So congratulations that you come this long way along with me to build all of these models. Okay, so it's a good achievement for you if you are doing it for the very first time, right? And yeah, So once this is done, then what we can do, we can, visualize the internal representation of this convolution layers, right? So we have built three convolution layers here, right? In the model, if you see, this is our first layer, right? Then this is the second layer, right? And this is the third layer. So we can visualize what the layers are actually learning. Okay, so we have done the coding, right? We have understood, okay, what it is doing from a, I mean, array perspective or mathematical perspective, right? But visually how it looks, for this is the code. This is also again a boilerplate code, and for this you have to understand the model.layers API, right? So first what we are doing, we are calling layer.output for layer in model.layers. Okay, so okay, so this is the successive outputs that we are storing here, right? Now what we are trying to do, we are trying to build the visualization models, right? So for that we are calling model method from the models module, and we are providing the inputs as our model dot inputs and our outputs as successive outputs. And what is our successive outputs? This array basically is nothing but layer dot output for all the layers in our model dot layers, right? So from model dot layers we are getting the outputs, and we are getting model inputs from model dot inputs. Okay, so there is nothing called model dot outputs, that you have to remember, right? So model dot inputs, we know the inputs you are getting from the model, and model dot layers will provide you the output in terms of your layer dot output. That means model dot layers is nothing but a list, and within that list there will be each element, there will be some elements, and within every element there will be one output as a key. Okay, so this two line, I think it's clear. Now what you are doing right now, again we are preparing a random input image from the training set, as we have seen here, right? This 4 by 4 classification, or what visualization of image. So it will create the image, it will take the random image of cats and dogs, and then it will do the matrix reshaping basically. So once that is done, so we are just calling this visualization model, and we are passing our image, and we are calling the predict method. Okay, so once we'll call it will store the feature maps basically. So these successive feature maps are nothing but object that will hold the feature maps. Feature maps are nothing but these representations of the convolution layers that it will learn, right? And then finally we are just displaying the basically feature map, okay, whatever it has learned. And these are some boilerplate codes, you just copy and paste. Okay, these things you don't have to learn, you can find it on internet. Okay, anyhow you just code, and then you understand what it is doing. So this is your con 2D for with a random cat image, right? Con 2D means your first layer. Okay, if you remember the way your model named your convolution neural network, the first one is con 2D, then your con 2D hyphen 1, then your con 2D hyphen 2, right? So when the image when the model got this random image first, this is how it is learning. So you can see a clear, I guess, focus on the eyes as well as on the nose, right? And you can also see this what ear, right? These things are getting much more focused, and especially this nose and eyes, for this cat, right? And then you can see the image after max pooling. Okay, and once your max pooling is done, then you can see the second one is your second convolution layer. Here it is learning a more low level detailed about the cat. Okay, features basically, you can see all of this here, and then again a pooling, then you can see another very low level details. The convolution layer, the third convolution layer is learning. Okay, so yeah, I don't know what it is learning, but it is definitely learning something, right? And this is the max pooling layers visualization. Okay, So this is how you can draw the intuition of convolution neural network and how it works. So this is the overall basic code that we have shown here, and you have remembered that when we are applying this model, right, we have stored the result of the output of accuracy loss in history object. So we can build a boilerplate, uh, plotting function, and we can plot all the training and validation accuracies for our overfitting and all the machine learning jargon purpose. So you can see here with all the epochs are increasing, our accuracy for training is also increasing, but the validation accuracy is stagnant after 8 epochs. Okay, and you can also see the validation loss got increased after 8 epochs. I think after 6 epochs mostly, yeah, from 6 epochs it can give a clear divergence. So it indicates that overfitting of model, right, where your validation loss is increasing, validation accuracy is at stagnation point of time, right? So we'll in later point of courses in machine learning and deep learning, right, we'll learn how to deal with all of this. So for this tutorial, so far I think it is enough for you to grasp, if you have grasped, okay, how to build a basic neural network using TensorFlow library, and how to understand basically the feature map visualizations. So that's it for this notebook. Now quickly shift to your PyTorch notebook. Okay, okay, I think it's disconnected. Same thing that we have implemented in TensorFlow, we are implementing here in PyTorch. Okay, so this is another interesting thing. Okay, so how we are doing it. So you remember there you have Keras, TensorFlow and all that stuff. So here we have Torch. Okay, so we have Torch Vision datasets, Torch Vision transformers, utils data. So here also, there also you have tf.utils, Keras.utils, right, from where you have imported, I forgotten what you have imported from the Keras utils. Okay, forget. Okay, let's leave there. Okay, so yeah, first thing, again, just leave this one also, right? So this course I'll let you know later. Okay, first what we are doing here, again, we are defining the batch size. So you have understood how we are dealing, or how we are doing working with the basically deep learning neural networks using TensorFlow, right? Same thing we are implementing, but here is the what example I have taken. I am using a Cypher 10 dataset, right? So it's an inbuilt available with PyTorch installation, right? So you don't have to prepare the data yourself, right? So data is already available. So first you are just providing the batch size, as your training contains 50,000 images. Okay, so batch size, you are, let's say, we are providing the 50, and you are providing the number of levels here, which is 10. Okay, so you're just calling this Cypher 10 to load the data, and you are giving, okay, just load it in data folder. Okay, so train true will download the training data set, and in transform you are providing the transformation. Okay, so what it will do, as your data set contains images, right, and you need to transfer the data or transform the data to tensors basically, so that your model can work along with the tensors, and it can do the viable learning, it can go through the viable learning and predict something, right? So that's why you need to do a transform on label as well as on features, if it is not already in that format, right? So that's why we call this transformation, and these transformations are nothing but we are using this torch vision.transforms module, from which we are using this method, right? So what it is composing, first it is converting the images to tensor. So this transforms dot to tensor, it will convert your image to tensor, so you will have the tensor. And second one is nothing but scaling, right? We are normalizing the tensor. The same thing we have implemented, if you remember, right, here the same thing we have implemented. So here this image size we have mentioning, right? So what it will do, it is understanding, okay, I'm getting an image of this shape, and then what we are doing scaling, right? So the same scaling we are also doing here, also we are doing normalization, right? Same thing. And download equals to true flag means if it is not already downloaded, it will download. Okay, so your training set is ready. Then what you can do, you can use. So this training set will download your required data. Now to iterate over your training set, you require one iterator, right? So that iterator for PyTorch is nothing but your data loader. So this data loader method provides you the ability to iterate over your training set. So you will call this data loader method, then you will pass this training set, then in batch you will pass the batch set, then you make shuffle equals to true if you want random shuffling, right? Normally your images are ordered, so for better understanding or a better model performance, we normally used to put shuffle equals to true, and then you provide okay if you require any workers. Okay, so in for parallel your training purpose. So for now, let's just ignore this one. Okay, so your training data is ready. Same thing we are doing for testing. Same kind of transformation we will be requiring on top of the images, right? Because whatever shape will be there in training will be required for testing as well. And once that is done, we are just calling the data loader iterator again for testing data set as well. Okay, so this is done. You can see okay 50,000 data is there in training set. For testing there is 10,000, and the number of batches per epoch is 1,000. So what is this? As we have mentioned, the batch size is 50, right? So to complete one training you will be required 50,000 divided by 50, that means 100 batches, right? So that's it is. So you have loaded the data, then again you have to define the network, right? So in case of TensorFlow, we have used a sequential API, right, for defining the model. Here we are using torch.nn. So this torch.nn is nothing but our neural network implementation module of PyTorch, and everything within PyTorch for deep learning we can implement using this torch.nn. Basically this module contains. So we are just using it, and then again we are using another functional module as if. So we are just importing this two, then we, as in your loader, right, your required format is ready. So now what you required the convolution layers, right? So here you are passing that okay my first layer, it will have 3 input channels, right? And then let's say my kernel size is nothing but your filter size in convolution. Okay, so you are using a kernel size 5, means in case of sequential API you have to write it 5,5. Okay, so that same thing got changed it as a variable here as 5, and this 12 is nothing but the number of output channels, that means the number of filters you want. So I want 12 filter of 5 cross 5, I want the stripe to be 1, and I want the padding to be 1. Okay, these things also you can implement in TensorFlow. And if you don't know what's the stripe, what's the padding, I will again request you to please go through this tutorial where I have explicitly mentioned, given deep focus on each of these topics. And we also have done coding for striding, padding, kernel. Okay, all of this. Now this is my first convolution. Then what we are doing a batch normalization of this. Okay, then once that is done, what we are doing, we are again implementing another convolution. Okay, in this case what will be my input channel will be the output channel of the previous convolution, right? That means 12, and we are again expecting implementing 5 cross 5 kernel of 12 5 cross 5 kernel here. So my output channel will be 12 and my kernel size will be 5, that means your filter size. Then again normalization we are applying, and once we applied a normalization, then what we are doing, we are applying one batch pooling of max pool method. So we are doing a 2 cross 2 max pool. Okay, then once that is done, then we are just again calling a convolution here, where now we want 24 filters to be applied of 5 cross 5 filter size. Once that is done, again we are doing batch normalization. Okay, and once that is done, again we are calling another convolution. Here also we are applying 24 filters of 5 cross 5, and that's it. Once that is done, as we have used here flatten to flatten it out, and the volume, whatever volume is left, right, after all this convolution to flatten out, and then we are connecting with a dense network and output. The same thing we are doing here. So once that is done, we are just calling this FC1. That means it will it's a linear network basically, where our last output is 24, and we are just applying, let's say, another 10 cross 10. So this many nodes in input, and the output will be 10. Why 10? Because your cipher is a 10 level data set, right? That means it contains 10 levels, so that's why we pass 10 as output. In our dogs and cat data set, it will be 2. Okay, so once that is done, we are just applying now non-linearities in each one of these convolutions, right? So for convolution 1 input, what will be my non-linearity? We are applying this functional dot ReLU. Okay, this f dot ReLU means what is f? F we have taken from this module, right? Torch and then dot functional. So f dot ReLU will give us the ReLU non-linearity activation, and we are just passing it on first layer. Then in second layer also we are passing non-linear convolution, and again we are passing it on PN4, that means this con4 convolution, and again we are passing it on con5. Okay, so in total all my con1, con2, con3, con4 and con5, these four set of layers have this ReLU non-linearity. Okay, and in case of self pool, there is no requirement of non-linearity, right? Because the model is not learning anything, right? So that's why in in case of third scenario, where you are only applying pooling, what you are doing, just self dot pool, and you are passing the output. Okay, so yeah, once all this done, at last we are just, the output dot view is nothing but doing the whatever the reshaping required. And once that is done, we are finally calling this linear network basically at the last, where it will provide us the 10 nodes output. Okay, so this is we have implemented in forward method, and within this forward method we used to implement the neural networks calling function. So this is the calling function you have to remember of this neural network, and this is the definition, right? This is the definition thing that we have implemented. So once that is done, it's nothing but a Python class, right? Within Python class, it's a self constructor, and this super is the method that we normally use to call the parent class, right? So this is normally used to call the parent class methods basically, right? So until and unless you use this super, you cannot call all of this. Okay, so yeah, once that is done, you just initiate the model, and as you have mentioned, you are passing network, right? So this network, you just initiate this network. Okay, network class basically, so it will initiate the model, and then you can print the model. So you can see your first layer is nothing but a convolution, then you are doing batch normalization, then there is no pooling, right? You remember, then directly another convolution, then pooling, then directly two convolution, then one linear. Okay, where your feature input is 10 times 10 times 24, and your output is 10. Okay, and where you have haven't added any bias term, that means by default you are adding bias. Okay, now next thing, what your model is defined, then you have to do just remember, in case of TensorFlow, model.compile, right? So for compilation of model, what you require the loss function and the optimizer, right? It's the same thing we are going to do. So from torch.optim, we are using Adam optimizer here, and in there we use RMS prop, right? And the loss function, what we are using, we are using cross entropy loss. Okay, and in case of our previous use case, we have used binary cross entropy, right? And this cross entropy is nothing but your categorical cross entropy. Okay, so once that is done, you are calling you initializing the optimizer variable, and in this optimizer variable you are calling this Adam function, where you are passing. So the optimizer, what is the job of the optimizer in a gradient descent method? Basically, it will do the back propagation and all that stuff, right? And it will basically work as an accelerator. So you will pass the parameters, the learnable parameters at the learning rate and a weight decay. Okay, these three things you need to pass to your optimizer. So your loss function and optimizer, the two required parameter for training is done. So yeah, you are good to go for training, right? So now next, how to train the model in PyTorch. So from torch.autocad, you are importing variables. So this is required to store the variables, right? And for training purposes. And this is a basic boilerplate code for training PyTorch models. Okay, that we have taken. And this function is doing just the model save. So torch.save it is calling, and it is just providing the path that we have mentioned here, and .pth is the save what model format for PyTorch. Okay, so this is one function. It's a boilerplate function. Again, your test accuracy, all these are boilerplate function, and we will be discussing about all of these individual code blocks in our PyTorch tutorial very detailedly, so that people who are not interested that much in PyTorch but they want to know how to implement the same project, right? So will not go into details about each and every line of PyTorch here. So in that course of PyTorch we'll be discussing all of this. So yeah, this train method will train your basically model. So and once your model is trained, this method is nothing but your testing. This is the image show method that will show up the image. This is for test batches. Okay, now if you call the train and you will pass the epoch, right? The train will take the number of epochs you wanted to train the model. It will train the model. So we have done that, right? And once the training is finished, you can call this test accuracy method basically. So this test accuracy, where it is, test accuracy method, right? Where is test accuracy? Yeah, this one, right? So it will print out the accuracy or test data set. Then you can load the data. Then after loading the data, right, you can call the test batch. So whatever we have prepared here, right, this test batch. So what it will do, it will show up the you know testing data sets as well as the real and predicted values. Okay, so you can see this first one is cat, that's a real level, and the prediction is also cat. The second one is the sheep, the prediction is also a sheep. Okay, so in that way. Now after that is done, what we have done here, we have uploaded one dog's image. Okay, so as you can see, it's a downloaded image that we have opened using PIL. Okay, PIL library. And once that is done, same thing what we have performed right here, storing all the model parameters in and out parameters, and as well as your your convolution layers, all the feature maps that we have stored. Same thing we are doing here. As you can see, we are storing the weights, we are storing the convolution layers, right? So once you are applying the same method, so you can we are just printing the number of convolution layers, and we are just printing all the layers, right? So all the convolution details. So once that is done, what we are doing then, we are just calling the basically visualization of your output of each and every convolution. So you can see we have four number of convolution layer, right, in our model. You can see here, right? Well, without I think there is only one pooling and four number of outputs. It is, yeah. So you can see conv1, conv2, conv4, and conv5. There is four number of convolution layer we are having. So these are the output of this four convolution, right? So you can see and try to figure out how the same CNN we have implemented in TensorFlow as well as PyTorch, right? And these are the visualization of this dog image that we have just uploaded and got the prediction for it. Okay, so yeah, this is the tutorial for your first, I think, in hand CNN after low level implementation of padding, pooling, striding, all of this. So yeah, I hope you have learned how to implement basic convolutional neural network in TensorFlow as well as in PyTorch. And in the next video, we will discuss more about CNN. So stay tuned, like, share, subscribe if you have gained any knowledge out of this tutorials. Thank you very much.